Hey everyone, and welcome to The Hidden Layer. Today, we're digging into a really fascinating research paper that tackles a huge challenge for pretty much any engineer working with AI right now. How do you really know if an AI's code review is actually any good? And more importantly, we're going to show you how to take these ideas and apply them in the real world.
Okay, so let's just get right into it. Picture this. Your AI coding assistant just drops a massive pull request. 1,000 lines of code. Looks okay on the surface, right? But is it actually fixing the problem? Or is it maybe, just maybe, silently introducing some weird bug that's going to turn into your worst nightmare in a month? This isn't just a thought experiment. It's the daily grind for developers now.
You know, the thing is, AI is just pumping out this tsunami of code, and our ability to manually review it has become a huge bottleneck. So in this explainer, we're going to break down why the old way we've been judging AI reviewers is just totally broken. And then we'll dive into a brilliant new test-based approach from this paper, a method that's absolutely crucial if you want to build AI agents you can actually trust.
And hey, you're definitely going to want to stick around because near the end, I'm sharing a super practical tip pulled right from this research about how one simple markdown file can seriously boost your AI's ability to catch the problems that actually matter for your project.
All right, so let's get into the problem here. The core issue this paper is tackling is just the sheer volume of AI-generated code. We just can't keep up. As humans, our ability to review all of it is, well, it's limited. This creates a massive quality bottleneck, which means we're now using AI agents to review the code from other AIs, which of course leads to the big question, how do we even grade the AI reviewer?
Right now, the standard way to do this in the industry is to see if an AI's review comment sounds like something a human would write. We use these metrics that basically just measure how similar the words are. But is that really a smart way to do it? The researchers behind this paper argue that this is a fundamentally flawed way of looking at things.
Okay, check this out. This slide from the paper is the perfect example. On the left, you've got a human reviewer. On the right, an AI agent. Now, both of them spotted the exact same bug, a potential crash if the input is messed up. But just look at how they worded it. They are completely, totally different.
And this is where it all clicks into place. These common metrics we use, like blue or rouge, they're basically just glorified word counters. They're looking for text overlap. So for those two comments we just saw, they'd get a terrible similarity score. But the meaning, the actual point of the review, is identical. So what we've been doing is measuring the wrong thing. We don't care if the AI uses the same words. We care if it found a real problem. And look, here's the hard data to back it up, pulled right from their research. For that last example, look at the blue U4 score, a flat 0. Rouge L is barely scraping by at 7. Even a fancier metric like embedding similarity only gets about halfway there. These tools are completely missing the point that both reviews identified the exact same bug. Okay, so if just comparing words is a dead end, what's the alternative? Let's get into the solution that the paper proposes. It's a really elegant new benchmark they call CRB. CRAB stands for Code Review Agent Benchmark. And its main idea is, well, it's simple, but it's also brilliant. It says, stop reading the comments. Instead, evaluate an AI's review based on one simple question. Did its suggestion lead to a real, verifiable code fix that makes a failing test pass? So here's how this fail-then-pass logic works, and it's actually really clever. First, they take a real bug report from a human, and they write an automated test based on it. Of course, this test fails on the buggy code. Then, step 2, they hand that same buggy code to an AI agent to review. Third, another AI, a coding agent, tries to apply the reviewer's suggestion. And then, the final, most important step, they run that test again. If it passes now, we know the AI reviewer's suggestion was good. It's objective. It's provable.
And this diagram from the paper gives you that bird's eye view. Up top, you see the benchmark creation. They're turning human insights into solid, executable tests. And down below is the evaluation loop, where an AI's review is judged purely on its ability to make that test pass. It's just a really clean, powerful system.
All right, so the method is super solid. But what happens when you actually put today's top AI agents to the test using crap? Well, the results are, they're a pretty fascinating reality check for all of us. So this is the number that really jumped out at me. When the researchers combined the results from all the AI agents they tested, we're talking the big names, Devin, Claude, Codex, all of them together, were only able to identify and fix 41.5% of the issues that humans originally caught. That's a pretty big gap.
And this Venn diagram, wow, it tells such a story. It shows you which agents caught which bugs. The first thing you notice is just how tiny that overlap in the middle is. Each AI has its own strengths, right? It's catching a different piece of the pie. But the bigger story is that giant area of issues that all of them just missed completely.
But, and this is super important, the researchers have a really smart take on this. They say this doesn't mean the AIs aren't bad at code review. It just means they're looking for different kinds of things than human reviewers are. It's not about failure, it's about a difference in focus. And right there, in that difference, that's where the opportunity is.
And this chart, it just lays it all out perfectly. The solid bars, those are the AI reviewers. The pattern bars are us, the humans. And notice how the AIs are just masters of robustness? They're amazing at finding those obscure edge cases and potential crashes. But humans, we're way more focused on long-term maintainability. You know, things like code complexity, how readable it is, and whether it fits the project's design patterns.
Okay, so this research is awesome. But what does it actually mean for you, the applied engineer who's got to ship code tomorrow? How can we use this? Let's translate this stuff into some actionable takeaways you can start using right away. So takeaway number 1, and this is the big one. Stop thinking of your AI as a replacement for a human reviewer. Think of it as a specialized tool, a complement. Let your AI agent be like a tireless bloodhound for those robustness problems. Let it hunt down every possible edge case and error handling flaw. This frees up your human reviewers to focus on what we do best, protecting the high-level maintainability and design and all that unwritten tribal knowledge of your code base.
All right, remember that tip I promised you at the start? Well, here it is. And honestly, this is a game changer. The key to making your AI better at all those human-centric tasks is surprisingly simple. You have to give it context.
See, the research is clear. AIs are kind of clueless when it comes to your project's specific rules. Because, how would they know? It has no idea about your team's unique coding style or architectural patterns. The solution? Just tell it. Write down your project's style guides and design philosophy. The paper even suggests creating a simple file. You could call it agents.md, where you just spell out these rules for the AI. This one file can give the agent the context it needs to give you way more relevant feedback on maintainability.
And that brings us to the final big idea here, especially for anyone out there building or choosing these AI tools. The future of evaluating these things has to be based on tests, not text. If you want to build AI agents that are actually verifiable and reliable, you've got to move past these fuzzy text comparisons. Using objective fail-then-pass signals, just like the CCRA-B benchmark, that's how we build agents we can truly trust to improve our code, not just leave comments on it. So, at the end of the day, here's the bottom line. Your AI copilot isn't a perfect drop-in replacement for a human teammate. It's an incredibly powerful tool with a unique and, frankly, kinda alien set of skills. So the real question this research leaves us with is, how are you going to design a workflow that partners its strengths with yours? Let us know how you're using AI in your code reviews down in the comments. Thanks for tuning in to The Hidden Layer.